answer. Okay, now we'll take a situation where an object will be moving nearby a plane mirror. Object and plane mirror both will be moving. Then how to deal with such numericals? Both object and image, they are moving. Where the object is at a distance 15 centimeter. So what we do is like, this is the object distance, no? So first let's get into the concept of mirrors one. Okay, this is the where the image will be. If object is between C and F, image will be beyond C. Image will be beyond C. Any formula, as we take care of formula. 1 by V. Object distance, anything directed towards right should be positive. Or say towards left is positive, but the object distance, I'll measure opposite to incident ray. The incident rays are moving towards left, and the object distance I'll measure from pole, opposite incident ray. So therefore, this is minus 15. Focal length, minus 10. Again, the focal length also, how do I measure? PF, I'll measure PF towards right, but the incident rays are towards left. So therefore, PF should be negative. Focal length should be negative. Solving this. So where the image should be beyond CF, and we'll get here. What was the question? The question that is asked is find the velocity of image. It is not asking the position. We have to calculate the position of the image. So shall we say this is some x coordinate, or so like this is object distance u, and this is what that image distance. Now the object is not at rest, it's moving. As the object starts moving, so this object distance is going to vary. Correspondingly, the image distance also is going to change according to the formula. As this is a constant. So as this object distance changes, then definitely V should change. So image distance also going to change. So therefore, what are V and U here now? They are variable. They are varying with the time. So let's differentiate with respect to time. I could have started theoretically, but I wanted students to generate. So it is at 15. Now let it be at after some time, like in 1 second, it will be at 13 centimeter. When you put minus 13, corresponding V will change. So even the image also will get displaced. As the object gets displaced, the image also gets displaced. So therefore, as the object is moving, the corresponding image will also move. Later on, I'll consider the motion of the mirror also. So therefore, what is our formula? The mirror formula will take help of this one, 1 by V. I'll differentiate this. This will become minus 1 by V square dV by dt. The first derivative of this. Similarly, minus 1 by U square du by dt. Focal length of mirror, radius of curvature of mirror will not change. So that will be constant. F is a constant. Derivative of constant will be 0. Then what is dV by dt? Rate of change of position of the image with respect to pole. And pole is a mirror. So therefore, this will become velocity of image with respect to mirror along x-axis by V square. Don't get confused. V is not final velocity. Image position. Here we have symbol. What is U? U is not initial velocity. V is final velocity. U is object distance. V is the image distance. Minus. This will become VOMX by U square equal to 0. So what is finally? VIMX is equal to minus of and this should be the magnification. This formula should be magnification. Okay, further let's calculate the thing that one. So what is the value of further? Let me expand this. So VIX minus VMX. VOX minus VMX. The formula relative velocity VAB. VAB, how you write VAB? VA bar minus VB bar. Relative velocity, if you can recollect. Similarly, VIMX, velocity of image with respect to mirror along x-axis, is equal to VIX minus VMX. Velocity of object with respect to mirror along x-axis. Velocity of object along x-axis minus velocity of mirror along x-axis. These are the terms. Okay, let's define what they are. What they are. VIX, VOX, VMX. Velocity of image with respect to ground along x-axis. Velocity of VOX it is. Object, there's a velocity of mirror. Please do notice, I don't have any other colors. Yeah. Okay, I will pick up this. Yeah. Fine. So these are the symbols what we'll be using here with respect to ground along x-axis here. Okay, what is the question asked? Find the velocity of image in the given conditions. Do we know VMX? I'll directly come to this one. So VIX equal to VMX. VMX is how much? Plus 6. Minus V is how much? Minus 30. U is minus 15. VOX is minus 2. And further VMX, velocity of image. So velocity of mirror will be plus 6. So VIX is equal to, this will be 2, 4, minus 4, minus 8, minus 2, minus 6, minus 8, 8 4 ja 32. So this will be 32, 32 plus 6, 38. So velocity of image with respect to ground will be 38 centimeter per second. See, the just like from this derivative, this idea of the problem. As object distance varies, image distance varies. So let's take the derivative of object and image distance. So dv by dt will become the rate of change of position of the image with respect to mirror. Du by dt, rate of change of position of the object with respect to mirror. That is VOMX. So now if the mirror is attached, then what to do? If mirror is attached, what to do? If mirror is attached, what to do, that one? So in the formula, where all VMX is there, put 0. It will become very simple, no, for you. If mirror is attached, that this quantity will be 0. Then solve the problem. So I just directly took a case where object and mirror both are moving here. Now, is it possible where object attached and mirror moving? No problem. Then put VOX 0. Use this formula. So this is now a very generalized case what you have now. Yeah, better remember. I suggest you to remember this. And this will be much easier, no? I'll bring blue color. So I'll write down. It's a formula. So better remember. The yellow color one is an idea. It's an idea, that one. There's an end formula which we'll be using in the numericals here. So this is the idea, this one. Just we generate it. This is the formula which will be useful for us in solving numericals.